video, we're going to look at how to find equations of tangents and normals. Essentially, we're just finding equations of straight lines, so it's just using our y equals mx plus c stuff. So let's remind ourselves what tangents and normals are, and then let's do that. So remember, the tangent to a graph at a particular x value continues parallel at that point. So the diagram is drawn down here. At x equals a, this point here, we have a tangent at when I have a straight line running off it, it'll run parallel to the graph at that point. So what it really means is I need to know the gradient at this point here. Now the gradient at that point there is given by the derivative at a. Now a normal line, which the word normal is not necessarily in the methods course now, but we do perpendicular lines. That's what the normal is. It runs at right angles the other direction, so it completely cuts across it. Now remember, this tangent only just touches the graph there. It doesn't have like a secant or something where it crosses like this. It just touches the graph there and continues on. Now we'll eventually cross the graph again up here, but we're not trying to find the gradient of the tangent between the crossing. We're just trying to find the tangent's gradient by looking at the derivative locally here. Now when you're at perpendicular lines, remember two perpendicular lines with their gradients, they multiply to -1. So in our case here, that means the gradient of the tangent multiplied by the gradient of the normal will give you -1. So if you know one of them, you therefore know the other one, which is handy when you're often asked to find one or the other, or sometimes both. Like I said before, they're given a linear equation, so you can use y equals mx plus c in that form. Often with the normal, you'll end up with a fraction for your gradient, and when you have a fraction for your gradient, they often like to write it in standard form, which remember is ax plus by equals d. So if you ended up with something like y equals 1/2 x plus 3, you might often see, or it might be a multiple choice written and looked a bit differently without the fraction of a half. So you'd multiply everything by 2 to get this, and then you would subtract the x to get, oops, that for you. That's in standard form like this. Okay, so no fractions, whole numbers everywhere. So here are your steps. First of all, you need to find the gradient, just like you would normally with a straight line. You find the gradient using rise over run. In this case, though, the gradient is by finding the derivative. So to find the gradient of your tangent, it's just a derivative, and you substitute the x value that's given in. In the diagram here before, that was just the value of a marked down here, but the value of a, of course, can be anything depending on what you're given. The normal is given by -1 divided by that, because we said before the gradient of the tangent times the gradient of the normal gives you -1. If the gradient of the tangent is f dash of a, then to get, the normal by itself, you divide by f dash of a to get -1 over f dash of a like that. Then we have to find the coordinate of tangency, which means find the coordinate where at this point, where it happens right there. That's your coordinate of tangency, and that's given by the x value there at a, and then the a substituted into your original equation, and that'll give you a coordinate. So that's the coordinate of tangency there. And then find the equation. You do that by using one of these two options. It doesn't really matter. You can use either one, whatever you're comfortable using from way back in year 9 and year 10. So let's give this a go, a couple of equations. So find the equation of the tangent and the normal in the following cases. We've got two options here. So first of all, tangents and normals both need the derivative, so let's find it. So dy dx, for this first one I've used dy dx because it's a y, there's an x there, so dy dx. I haven't used f dash in this case because I haven't got f of x. So the derivative of x cubed we know is 3x squared. The derivative of -2x squared is -4x. And then you can say at x equals 1, the derivative is going to be with 1 substituted in, squared, and that gives you -1. So that means gradient of your tangent equals -1. Therefore, the gradient of your normal, like we said before, is -1 divided by the gradient of your tangent, which is -1, which happens to give you 1 overall, which is nice. So therefore, let's find your tangent. So y of the tangent must equal -1x plus c. Now to find your plus c, you need to have the coordinate where they cross, and that's something I have not found yet. So let's actually find that, because I did say we need to do that. The coordinate when x equals 1 is 1, comma, and then you're going to substitute 1 into your equation. You find you get 1 minus 2, which gives you negative 1. So the coordinate to substituting is 1, negative 1. This is the same for both graphs. Same for both cases. What is different is your gradients. So I'm going to substitute this coordinate and get negative 1 equals negative 1 times 1 plus c. Negative 1 equals negative 1 plus c. Oh, look at that. C is 0. So therefore, the equation of the tangent is equal to negative x plus c, which was 0. Now, it will not always work out so nicely like that. I should highlight the tangent stuff all the way through. There we go. And I'll underline that and there. Won't always work that way, but it's the same idea. So let's do the equation of the normal. So we've got a gradient of 1, so you get 1x plus c this time. We're going to substitute negative 1 and 1 into the equation. Your negative 1 equals 1 plus c, c equals negative 2. So the equation of the normal is x minus 2. And I'll do that in orange. Tell us to see what's going on here. And then all the way down there. Again, I'll underline the gradient there. Okay. Let's do one more example. This one's a little bit different because it's got a sign involved, but the setup's still the same. Must find the derivative first. Okay, so the derivative of sine is cosine of pi x, and you bring the derivative of the bit inside at the front. Now, the derivative of this is pi. That comes at the front there. That's using the chain rule. And plus 1, derivative is 0. So when x equals 1/4, you're going to end up with the derivative being equal to pi times by cosine of pi and 4, which cosine of pi and 4 we know is 1 on root 2. So you end up with pi on root 2, which you can also write as pi root 2 over 2. If you rationalize the denominator, you do that by multiplying top and bottom by root 2. Root 2 times root 2 is 2, and the top becomes pi root 2. Doesn't really matter. Which then means that's therefore the gradient of your tangent is equal to pi root 2 over 2. And the gradient of the normal then is negative 1 divided by that, which gives you negative 2 over pi root 2. Again, we don't like having a root in the bottom if we can avoid it, so we're going to multiply by our root 2's, and you're going to end up with negative root 2 over 2 pi because, over pi, because root 2 times root 2 is 2. That's going to cancel with that 2 there, and you're left with negative root 2 over pi. So there's the gradient of your normal, and then there's the gradient of your tangent. Let's find the coordinate where it is a tangent. So we're now going to have the coordinate. So when x equals 1/4, y is going to be equal to sine of pi over 4, because a pi times a quarter is pi 4, plus 1, and that'll give you 1 on root 2 plus 1. So your coordinate is 1/4, comma, 1 on root 2 plus 1. Now let's find the equation of the tangent. So tangent we know is going to be the gradient of the tangent, which we said was pi root 2 over 2, x plus c, and let's substitute all our values in. So we're going to get 1 on root 2 plus 1 equals pi root 2 over 2 times 1/4 plus c. I'm going to simplify that. I'm actually going to, on the left-hand side here, I'm going to make this thing over 2, so I'm going to make that root 2 on 2, purely because I have pi root 2 over, I have a whole number over here in the denominator, so it's nice to do that. All right, so C then is going to be given by root 2 over 2 plus 1 minus pi root 2 over 8, which all over a common denominator, this one must be over 8, so you times it by 4 root 2. To make that over 8, you times it by 8, plus 8 minus pi root 2 all over 8. So the tangent then is given by the gradient of the tangent times x plus your C value. And that is quite long and not very nice looking, but it is valid and it can certainly come up in your exams, and that is your tangent line there. So let's now give the normal line a go. So here's our normal line. Okay, so normal line. We've got yn is equal to mx plus c. We know our m, though, is given by negative root 2 over pi. And now we substitute a quarter in, and we substitute the 1 and root 2 plus 1. So 1 and root 2 plus 1 equals negative root 2 on pi times a quarter plus c. 1 and root 2 plus 1 equals negative root 2 over 4 pi plus c. And then to get c, you can add it across here. 1 and root 2 plus 1 plus root 2 over 4 pi. Now there's really no hope for us here to try and get a nice common denominator. So you could just leave c like that. If you really want to, you can get common denominator, which would be 4 pi root 2, which you get 4 pi there plus 4 pi root 2 there plus 2 would be there. But I think at this point that will be sufficient for your y-intercept. So therefore, the gradient of the normal, that's a terrible n that I've written. Let's try that again. Will be negative root 2 on pi times x plus 1 on root 2 plus 1 plus root 2 on 4 pi. So this whole thing here becomes your y-intercept, despite how nasty it looks, and that there is your gradient. So there's the equation of the normal. Slightly more difficult algebra, but the process is exactly the same as the first one, and that is how you do tangents and normals.